This video I'll show you how to create this part. Start a new part. Now one thing you need to do is look at the geometry that you're dealing with. Because of the circular, the cylindrical parts of this object, there's really, in my mind, there's only one sketch you want to start with. I'm going to build this around that origin. So I'm going to line that up there and put those two circular features, and I'll dimension those. As well as the distance between them. Now to make it symmetrical, then dimension from the center to that origin, and since that's 4 total, just make that 2. And then I have to connect this. The easiest way to do that again is use the rectangle tool. You can draw it with lines, but the rectangle is a lot quicker, and I'm again just going to sketch that rectangle. And dimensionally it is 3/4 tall. Overall length is 6.5. And again, see, it's not centered, so I have to add a dimension from there to there. Half of 6.5 would be 3.25. And I want to make sure it's centered vertically as well, so add a dimension that way. Half of 0.75 would be 0.375. Now let's use our trim tool. Get rid of the things we don't want. And sometimes when you do this, you'll lose some of your dimensions. Some things will change. You just go in and add some more dimensions. So if you'll notice, these circular objects are showing up as blue because we did cut them, but it says that would be over-constrained. Now the other thing to check, I think I have everything I need on this so far. We can come up here and say fully define the sketch and just see what shows up. Gotta kind of look through the gobbledygook here. I don't think there's anything that we're really lacking on that. I am going to go ahead and put these holes in this though. The holes in the two ends here. And that's 3/4 hole. Let's go ahead and extrude this. And I will extrude it about the mid-plane. And that's 4 inches. Okay, so the other thing I want to add to this is there's 2 counterbored holes. There's 2 counterbored holes in that surface there. And the way to do that, now you could generate those by doing a couple of sketches, a couple of extrusions. The easiest way to do that is by using the hole wizard. So the hole wizard, let's click on that. The hole wizard will generate counterbores, countersinks. It'll also do threaded holes. It will do counterbored slots, countersunk slots. It will do all kinds of different things. So it's really handy, quick tool, especially if you have lots of features. Imagine having 100 counterbored holes. You're not going to want to do 2 sketches, 2 extrude cuts for all of those 100 holes. So let's look at the standard. Make sure you're using the right standard, and it's typically going to be ANSI metric or ANSI inch. In this case, we're going to do the ANSI inch. For the bolt, the default one is some kind of weird binding head screw. Don't use that. Typically what we're going to do with a counterbore is use a socket head cap screw. And the size, in this case, the size of it is a 3/8. If you want to make custom sizes, just click on that and you can adjust all of those parameters. Let's just use the standard size for a 3/8, and the end condition would be the small diameter hole. Remember, with a counterboard, the small hole goes all the way through. The counterboard hole just creates a pocket with a depth, and that'll be the standard size unless you want to change that. So then you have to go, don't check mark it, click over here to this tab that says position, and if you see what it says, select the face. So just click on the face in the general place that you're going to want the counterboard to be. So I got one there, and I have one there. Now don't hit enter or anything yet, because what we're going to do is go directly to Smart Dimension, and then we're going to put our dimensions, because those are just loosely placed on that right now. And that's 3/4. And likewise, that's 3/4. Since those are in the center of the part, which is 6.5 long, that's going to be 3.25. And that one would also be 3.25. I guess I got lucky on those. I hit the midpoints. Okay, and check it. And you'll see it generates the counterbore hole. So counterbore isn't that big of a deal, but threaded holes, countersunk holes, those are take a lot more time to create. So that's a really quick and easy to generate something like that. I will show you just one more thing quickly. I've already got this drawing. I'll just pull that up and show you. So to dimension counterbores, two things. Dimension the location. So here I have from the side over and from the top down, I know where those are located, but also the size. There's two different diameters, and there's also a depth associated with the larger diameter. You can just use Smart Dimension and make your own, or you can use this hole call out tool, which is a really clever. You just click on that hole, pull it out here, and it'll actually accept all the values. Now if you wanted to change those, you want to override them, you can, but even knows that there's two of them, so it's a quick and easy way. If you read that, what it says is there's two of those where the 0.41 goes through, so that's the clearance hole for a 3/8 bolt. And then the counterbore, the diameter of the counterbore, so that's the big diameter, is 0.63. That's big enough for the socket head cap screw to fit down in, and the depth of the counterbore is 3/8, so that's how you would read that. And then you're going to the counterbores are going to show up in your other views as well. Remember, we're not going to dimension the hidden line. So I see sometimes students will want to dimension that depth of that counterbore. The note will take care of that, so it makes it unnecessary for you to violate that rule of dimension to a hidden line. Now when you dimension this, obviously we've got that 3/4. You also want to remember how we constrained this. You also want to do the same thing. From the center line, you want to call out what that space is there, so that way you know that that feature is centered on the part, because this 3/4 piece could be shifted up or could be shifted down, so that eliminates that possibility.